Welcome to episode 24, Azure Resources and Resource Groups Explained, where we ground the cloud in its most basic building blocks. A resource is any manageable item you create, configure, and monitor, such as a virtual machine, a database, or a storage account. Think of a resource as the smallest meaningful thing you can deploy and own. This matters because every permission, billable meter, and operational action ultimately lands on resources. Imagine launching a simple web app. The site, the database behind it, and the key vault for secrets are each separate resources you can control. A common misconception is that resources are just labels on a map. In reality, they carry state, identity, and policy. To make practical progress, learn how to list, show, and update single resources reliably. Doing so aligns your day-to-day work with the goal of precise, predictable operations in Azure.
Names, identifiers, and scope give resources their place in the hierarchy. A name helps humans recognize an item, while a unique resource identifier anchors that item within a subscription and a region. Scope defines where an action applies, whether to one resource, a group, a subscription, or a management group. This matters because a delete at the wrong scope can remove far more than intended. Consider a team that grants broad rights at subscription scope so a quick fix is easier. Weeks later, an automatic script removes dozens of items by accident. The detail to remember is that scope is explicit and layered. When in doubt, narrow the scope to the smallest unit that still accomplishes the task. Clear scoping supports safer operations and cleaner audits.
A resource group is a container that organizes resources with a shared lifecycle. Resources in the same group are usually deployed, updated, monitored, and retired together. The group does not change what a resource is, it changes how you manage it as part of a set. This matters because teams need a handle to gather logs, apply policies, and measure costs for related items in one place. Picture an application stack that includes compute, data, networking, and secrets. Placing them in a single group makes day two operations less scattered. A misconception is that a group equals a security boundary. It is mainly a management boundary. Treat the group as a lifecycle tool, not as a firewall. Doing so keeps your structure simple and purposeful.
Managing deployments as units keeps complexity under control. When you deploy, update, or delete, aim to act on the entire resource group that represents an application or environment. This approach reduces partial changes that leave systems in a half-configured state. It matters because consistency is the quiet force behind reliability. Imagine rolling out a new version of a web service and updating only the compute tier. The monitoring or secrets may lag and trigger errors. Acting at group level helps coordinate all parts that must move together. The practical move is to define what belongs in a unit and script or template the whole set. This rhythm turns changes into predictable events rather than risky interventions. Tags add structured meaning to resources and groups, turning raw inventories into understandable portfolios. A tag is a simple key and value that can express owner, cost center, environment, or support contact. Tags matter because they power reporting, budgets, and alerts without changing the resource itself. Consider two teams sharing a subscription. Accurate tags make it easy to divide costs and assign accountability. A common mistake is inconsistent casing or spelling, which fractures reports and hides spend. Create a small standard like owner, application, environment, and compliance, and enforce it consistently. Over time, these tags become the backbone of chargeback, dashboards, and cleanup. Clear tags tell the story of who owns what and why it exists. Locks protect important items from accidental change or deletion. You can place a lock on a resource or on an entire resource group to block destructive actions. This matters because powerful tools also make powerful mistakes possible. Picture an engineer cleaning up test resources with a bulk delete command and accidentally selecting a production group. A delete lock stops the action and buys time. A misconception is that locks are only for final production. They are also useful during risky migrations. Use delete locks for critical assets and read-only locks when configuration must be frozen for a period. The habit of locking before major work reduces regret and supports safer collaboration. Authorization should align with resource boundaries, and that is where role-based access control comes in. Role-based access control, which we can call RBAC, allows you to grant the least rights required at the smallest practical scope. Assign roles at resource level when only one item is relevant, and at group level when the whole stack is in play. This matters because broad rights at subscription level often exceed real needs and create audit findings later. Imagine a contractor who only maintains storage but can also modify networking because the role was assigned too high. A better pattern is to define roles per team and map them to the scopes they truly own. Clear scoping in RBAC supports accountability and reduces risk. Policy turns intent into automated guardrails at the group scope and beyond. A policy can require tags, enforce regions, restrict resource types, or audit configurations. Applying policy at a resource group lets you shape behavior for a single application or environment without affecting the entire subscription. This matters because prevention is easier than cleanup. Imagine blocking public endpoints for databases by policy so that even hurried deployments stay safe. People sometimes think policy is only for large enterprises. In practice, it helps any team reduce drift. Start with audit-only policies to learn, then move to deny when confidence grows. Policy at the right scope supports consistent, compliant deployments. How you organize groups affects clarity and agility. The common patterns are by application, by environment, or by team, and many organizations combine them. Organizing by application places all components for one product together, which simplifies changes. Organizing by environment separates production from test and development, which supports stricter controls. Organizing by team can mirror ownership but may scatter shared services. This matters because structure influences who can act and how fast. Picture a production outage that needs a coordinated change. A clear grouping makes the blast radius and responsibilities obvious. Choose a scheme, document it, and apply it consistently so new projects fit without debate. Template-driven deployments make your structure repeatable and testable. A template captures the desired state of resources, their properties, and their relationships. When you run the template, Azure compares desired state to actual state and applies changes safely. This matters because manual clicks drift over time and are hard to audit. Picture spinning up a new environment for a feature branch. A template creates it the same way every time. A misconception is that templates are only for large systems. Even small stacks benefit from predictability. Add parameters for names and sizes, and keep outputs that report key identifiers. Over time, templates become living documentation and a reliable recovery plan. Moving resources between groups is sometimes necessary, yet it must be done carefully. Not every resource type supports moves, and dependencies can block the operation. This matters because an incomplete plan can leave an application split across groups. Imagine moving a database without its private endpoints and watching connections fail. Before moving, map dependencies, confirm supported types, and schedule a maintenance window if needed. Test the move in a lower environment to learn the steps and timing. If a move is risky, consider redeployment through a template and a controlled cutover. Safe moves protect uptime and preserve clean organization. Troubleshooting failed deployments is faster when you follow a simple method. Start by reading the error in plain language, which usually points to a missing property, an unsupported type, or a permission gap. Check scope and role assignments to confirm the caller can act where the template is targeting. Validate provider registrations and application programming interface versions to rule out schema mismatches. This matters because guessing wastes time while logs already hold clues. Create a small reproduction that deploys only the failing piece and iterate until it succeeds. Add outputs to print important identifiers for next steps. A steady routine turns failures into learning and keeps delivery moving.
Resource organization is the quiet structure that lets cloud work scale without chaos. Names and identifiers anchor items. Groups bundle lifecycles. Tags explain ownership. Locks prevent harm, and role-based access control and policy shape safe behavior. Templates capture desired state so environments can be created, updated, and repaired with confidence. When moves are required, deliberate planning avoids surprises. And when deployments fail, a calm checklist finds the cause. These practices are simple in pieces, yet powerful together. By treating organization as part of design, you build systems that are easier to change, easier to audit, and easier to trust. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.